Okay, just a polygon. Then I scattered a couple of points, which I'm going to copy some lines onto them. And the lines themselves are just regular lines, nothing much. Just being resampled. So I use a copy to point node to copy these lines and the points, and I'm also deforming them with this sine wave function. So I get this wave over here, and I'm using the iteration for the for each loop to slightly add some variation on each line on the speed. So if you can go through this Vex code, so I'm just creating the parameters for the sine wave function. Then I'm taking the iteration, which is from this node over here. So I'm just taking this iteration, randomizing it and fitting it between 0.95 to 1, and multiplying it on the speed value. And then I'd use all these parameters in the sine wave function to affect the position y. Yeah, so I'm getting these lines. Right, yeah. Okay, just play around with this. You can see the frequency, what it does, and the offset, which is mostly controlled by time, by frame. But here, that's why it's just moving, and the scale. And we also have the speed. If I go slightly faster and I play, you can see it moves much faster than the original speed I have. Yeah, so those will be the emitters and also the lines you can see on the render. And right here, I'm also creating the curve force. It's also just starting with the line, we're sampling it, then bending it to create a spring. Now on the bend node of this capturing, I just offsetted it a little bit so you can see it over here. Just a slight offset instead of being on 0, where it won't really affect anything as I twist, right? So I just slight offset that way. When I twist, I'll get a spring. So that's the idea why I had this offset over here. Then also applying a sine wave function is also, this time I'm just using a VOP node, but it's the same thing as the Vex, whichever one you pick. So that's the curve force, and this is what we get. Just like a spring that's going to be going around our lines like that, and also moving. So from this emitter lines, we just scatter some points, then add some velocity with noise. I'm just using a cow noise over there just to add those. You can also use the point vel nodes, point velocity node. You can just go to add noise. It's the same thing. It's not really necessary to do it like that. So now in the simulation itself, the sim itself. So you have this. This is the curve force, and I just have its influence scale very large, so you can capture all the points. That's why I have it like that. So firstly, if I just play the simulation, you can see. So right here, you can see that we have these points. We have some particles that are flowing, being affected with the curve force, and they also have some points that are going off. These are like some points are going loose. They're not being affected so much by the curve force. So what I'm doing here, I'm creating this group. First of all, I'm just switching on this just bond group so I can reach that point. So I can run this thing. I can assign groups on the points that have just been born. So what I'm doing here, I'm just creating a point of, I'm just randomly selecting a few points and assigning them to this group of loose group. I'm also changing the lifespan to be shorter, to be 1 to 2 instead of the original one. It's actually 3, 4. This actually means 2 to 4 because this value is actually added and also subtracted from the life expectancy. So that's That's what it be. If it is subtracted, it'll be 2, and if it's added, that's going to be 4, and that's to be the range of the lifespan. So I'm just changing that range to be shorter, to be 1 to 2. So these loose particles that are going to be grouped there, they're going to die faster. As you can see, they're actually dying faster. On the scaffolds itself, so this, everything just normal. The parameters just increase the influence scale, right? Nothing much to it. So what I'm just going to do here, I'm using this group over here to reduce the effect of the curve force on those points. So that's why they're going off, just following their own velocities somewhere else. They're not actually flowing with the curve force. So this is why I have the influence to be 0.1. If I had this at 1, maybe 0.75, not completely off, but if you play it and see, it's even these points will just still follow. They just keep continue to follow the curve. But with if now since I reduce that effect, those points will be free to follow all the other forces instead of following the curve force. So that's how I create the loose points. And after that, I just add this pop force noise, just with one with a smaller swill scale, and another with a bigger swill scale, just for detail, and pop kill at the end, just to kill the points at the end of the curve, because they usually just collect themselves over there instead of dying off. And this whole sim must be run at 25% the speed. The time scale is very reduced, so that's why everything is moving very slow. So after that, I just delete all the attributes. I just keep the one that I need for coloring and shading the particles. So I just have the light, the edge, normalized edge, velocity, and ID. So over here, you can check. So you can start with the color. So what I'm just doing over here with the color, I'm just creating this, just using the random ID, and I'm creating a channel ramp for from the randomized ID, just create the colors down here, and you can create your own kind of colors that you want, right? So I just have, most of them are blue and a few of them are white and green. That's how I'm getting those colors. And for the P scale, I have this code over here, this R scale, which is randomized scale. So I'm just using the randomized ID again, and just using that on the channel ramp, and scaling it overall with another scale, a P scale scale. It's right here. This is just an overall scale. So if I show this with disk, so you can see the scale. So this is the actual scale. I just bring them up about there. I think now you can see how they are. So the scale is just random, not be driven by age or anything. It's just random scale. And I'm just making sure most of the points are small and a few of them are big, right? That's how I'm getting this. So if I move this, you can see it's just most of them are small and some of them are big, right? Also, let's put this back. So that's for the current P scale. Now for the alpha, this I need to switch it back to points so you can see. If you see, they start like they're invisible, right? They're not actually dark, they're actually invisible, not actually black. So that's controlling the alpha of the particle. So as they continue to age, you can check over here, these points over here. When they die off, they don't just pop out. They slowly fade away. So I'm using the edge, the normalized edge, to control the alpha over here. So that's going to be right here, this normalized edge. So I just have this channel ramp, using the normalized edge to create this channel ramp over here. So they start out They start fading in, then they stay visible, and then they fade out. So that's how it's made, like that. And if you can just use this in pixels, I think it's going to be more pleasant, like that. So now out here, all I have is a camera and a single light just pointing to the side. Let me just create another camera so I can show you what I actually did and just parent it over here. So the same position as this camera of mine that I have. It's right here. So I did assign some materials to the points and the lines. So the curve themselves are just simple, just fetching this point color attribute which I've assigned. You can check it over there. And the particles themselves, I'm also fetching the color, the CD attribute from the points, and also the alpha right there to control the visibility. Yeah, so this color is going to be controlling the base color, the reflection, and most importantly, the emission color. So this is what our render is looking like with just a fresh new camera. There, no post effects, no nothing. So I need to add some bokeh effect. Just if you remember, we also have a light over here. That's where the light is coming from, and also the particles are actually have an emission. If you can just check this layer, we do have an emission on the particles itself. Everything else is mostly coming from the lines, right? The reflection and all. So if I go to opticals and enable bokeh right there, maybe if I change this f-stop and go way down to the point one to get this. So right there, and over here, if I just select the camera and press enter or press this multi-control thing, I don't know what it's called, the handle. I will just press enter the camera, right? I think you can seem to see this. You just keep your eye on this focus distance right here, right? So you control the focus right there. Or I can just move this handle, which is like this, so I can just see where focusing. So from here, I can also add rules if have been activated right there. Yes, for everybody, so everyone can see. So over here, I'm just going to decrease the threshold all the way down there, so you can have some glow, picking up the bright points, a little bit of soft, a little bit of intensity. So you can see another frame, how it all looks. I think there's less points, so let's just go forward. So that's how everything is made, and on the render node, can use a little match, just the passes, LVs, and sampling just on default. I just turned off this GI. Yeah, that's it.